and the x at which this occurs. When you see the word minimum or maximum, always remember it is turning point. It is called a turning point, which is basically just this part. This is the turning point. Basically, when it goes down over here and suddenly it rises again. This is the turning point. And to find the turning point, you just take a look at your graph. Which point is the lowest or which point is the highest for this graph? But for this graph, if you want to find the minimum or the turning point, just use the mean or the average theorem, which x1 plus x2, which is basically the value of the both x when the y value is the same. For example, like this part. This can be x1, this can be x2, this can be x1, or this can be x2. You can just take a random value, but if you have the graph, just say from the graph. Okay, for every single question like this, always state from the graph, the minimum value of y and the value of x at this occurs is basically the value of this turning point, which is at -2 and -1. So this is the x, this is the y. Just say the minimum from the graph, the minimum value of y is -1 and the value of x at this occurs is -2. So you get this three correct. Now the question states, state the equation of the line of symmetry of the graph. This is the easiest question, basically 1 mark. So the line of symmetry is just this line. It is a vertical line, and by our theorem, vertical line is equal to x equal to something, x equal to a, for example. And in this case, we see which point is this line lying on the x-axis, and in this case is lying on the -2. Basically, the line of symmetry, or basically our turning point, is lying on the line of symmetry, so x is just equal to 2. This is our line of symmetry, correct? Now, this is the hard question. If you cannot do this, skip. Remember to solve the first 4 questions correct. But this question is exceptionally hard. Basically, what this question is asking you to do is, when your y value is equal to another function, and you use this graph to find the function. What I mean by this is like, for example, if there's a line like this, for example, you call it like x plus 1. So if it's x plus 1 over here, you just state the intersection points are x squared minus 4x plus 3 equal to x plus 1. In this case, it's this point, this line. And in this case, well, it's different. The x plus 1 gives us this, but in this case, you are finding x squared plus 5x plus 2, which is basically x squared plus 4x plus 3 plus x minus 1. So if you move it to the other side, it will just be x squared plus 4x plus 3 equals to negative x plus 1. So after you get this result, you need to know that this represents the intersection points of these two functions, x squared plus 4x plus 3 and negative x plus 1. So this is the negative x plus 1. Basically, you need to plot it. In this case, I don't know how to plot, so I just plot a random line on here. Then you need to see which of the intersection points is the two functions intersecting each other. In this case, I have put a random line over here. So this is how you should find one of the intersection points. You need to use the dotted lines. Always use the dotted lines. when you are measuring and finding stuff. Dotted lines, dotted line, dotted line, dotted line, dotted line, dotted, 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 dotted. Every single thing dotted. You find the thing. You find the x value and the y value of this intersection with something something. And then also this one. Dotted dotted line, dotted dotted line. You get the x value and the y value of the intersection of this line. After you get it, you will know the intersection points and you will be able to solve the equation of this. Because the most important thing to solve an equation is to find its roots. Basically the answers and the value of x, basically. And to find the value of x, in this case the graphical method was to find the intersection points. This is how you should be solving